fuel consumption figures used in our fuel plan may not necessarily be true in practice. Therefore, a part of the in-flight procedure is to carry out regular fuel checks and compare the figures found with the planned figures. This lesson will very briefly examine some of the simple ways of monitoring the fuel flow in flight. One of the very earliest ways of comparing actual fuel consumption with the planned fuel consumption is to use a fuel monitoring graph as shown. Although this method is no longer used and does not form part of the examinations, it does hold some value in allowing you to visually perceive how fuel can be monitored. The graph is constructed so that the x-axis shows the distance to go in nautical miles and the y-axis is the planned fuel remaining. In the example, the final reserve fuel is 1000 kilograms and the alternate is 700 kilograms. The planned fuel at the destination is therefore 1700 kilograms. The planned trip fuel is 5000 kilograms. Contingency fuel is 5% of trip fuel at the start, reducing to 0 at the destination. Takeoff fuel is therefore 6950 kilograms. In the example, fuel checks are taken every hour and the result is plotted on the graph. Extrapolation of the results will give the expected fuel on arrival at the destination. In this example, there will be sufficient fuel. The fuel remaining is more than the final reserve fuel and alternate fuel. However, in this example, the fuel remaining line is going below the planned line, and therefore there is not sufficient fuel to land at the destination with reserves intact. In this case, an en route diversion or return to base would have to be considered. As we have already mentioned, this method of fuel monitoring is no longer used. In modern airliners, such calculations are done by the Flight Management System, FMS. This system is able to automatically carry out the same sort of fuel monitoring as we have already mentioned, and can extrapolate the fuel load at destination based on present patterns. If the calculated figure falls below the minimum required, a warning message is displayed. In order to foresee this, and to try and prevent it or plan for it, it would be far more prudent to carry out regular fuel checks. Monitoring fuel loads in flight to make sure the required amount is always present at any given moment is obviously standard practice in a cockpit. You may recall from your knowledge of the computerized flight plans that from this document it was possible to read off the planned fuel load, as shown here. Further on through the computerized flight plan, it was possible to see the fuel loads at various intervals, either using time sections, like every hour, or at specific route waypoints, like in the one shown here. For example, over the waypoint Epsom, the remaining fuel should be 3.3 tons. This can then be compared to the actual amount of fuel left as displayed in the FMS. If the actual fuel remaining is less than this, the aircraft is unable to arrive at the destination with the required reserves intact. Understanding the amount of fuel that the aircraft is burning and calculating the amount of fuel that will be remaining at the destination is an important part of safe navigation. It can be done in a number of ways. Taking the figures from the Operations Data Manual, CAP 697, and plotting the fuel remaining figures on the simple fuel monitoring graph. Or comparing the fuel remaining with the minimum requirement figures on the computerized flight plan. Or maybe just monitoring the figures as calculated by the flight management system.